have heard statements like chemotherapy is too expensive, chemotherapy failed, cancer is still growing. What's the problem here? The cancer refused to die and acquired chemotherapy resistance. Cancer cells are smart and develop mechanisms to survive and escape danger. Possibly, they learn how to repair the damage or they pump the drug out of the cell. For example, our current treatments for lymphoma are good, but insufficient to give the best results. Some therapies are unaffordable, they are not cancer cell specific, and let lots of patients get the disease back. This is why it's very important to select the best possible weapon to kill cancer with more specific, more effective, and less toxic treatments. Imagine having already developed a drug to help us with this problem. Sounds good, right? Well, the objective of my research is to investigate how approved drugs for other conditions help us destroy the cancer. Importantly, I am using a drug currently first on the list of the safest and the best drugs selected by World Health Organization. Now, it can sound even better. This drug is quite cheap and affordable to many patients. This strategy is called drug repurposing, which offers many advantages over developing an entirely new drug. Data have shown that creating and bringing to market one new drug costs pharmaceutical industry billions of dollars. Besides, I'm using 4 specialized drugs designed to target only specific proteins known to be overexpressed in cancer cells. The main question in my research is what will happen if I combine targeted therapies with a safe drug? The good news is that when I combine them in lower concentrations, I see decreased cancer metabolism and ability to divide, compared to higher concentrations of each drug used alone. Okay, this was interesting, so we went one step further. We saw that combinations reduced expression of proteins involved in cell division. What's more, we have isolated RNA molecules from treated cells to read their genetic profile. This helped us complete the puzzle which genes push cells to grow and block the therapy. Then we asked, what would happen if we turn off these genes and treat cells again? By finding answers, my research will be able to identify potential candidate genes responsible for stimulation of lymphoma cell growth and avoiding cell death. And most importantly, to make sure the combinatorial treatments in lower doses are less toxic, we plan to test them on healthy cells as well. I believe that our research will help develop effective, less toxic targeted therapies combined with safe profile drug and get better results. Also, this therapeutic strategy might lower the price of current treatments on the market and lower side effects and pain patients are going through. All of us working in the cancer treatment have the same goals: to identify mechanisms how cancer cells divide uncontrollably and to find a treatment with the best outcome. I hope that my research will contribute to both goals in the near future.